tonight. All right, does everybody have your page 148 for permutations and combinations? Okay, the first thing we're going to start out with is something called a factorial. And I gave you a little teaser about this the other day. When you see something like this, 5 with an exclamation mark behind it does not mean 5, right? It means 5 times 4 times 3 times 2 times 1. That's what it means. Not in this class, no. But that's what a factorial is. It means you take that number and you multiply it by every integer less than, excuse me, every positive integer less than and equal to that. Right here, this is what you put, 5 times 4 times 3 times 2 times 1, which equals 120. Yeah. Because if we included 0, then every answer would be 0. Exactly. Then what is the point of this little exercise? Okay. Now, when you do factorials, when you do factorials, especially bigger ones, I want you to think about how could I multiply numbers together easy. Let's look at 3 factorial. Now, 3 factorial is a pretty easy one anyway. How would I write out 3 factorial? It's just 3 times 2 times 1, which is 6. Now let's look at 7 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, I want you to not be quite so dependent on your calculator. Let's see if we can find any of these numbers that will multiply together to give us some nice things that make multiplication easier. Yeah, yeah, you could do that. I'd sure go right there. 5 times 2 is 10. Well, okay. So, well, look. What's 7 times 6? What's 42 times 10? 420. So you got 420 times 12. Go to your calculator. 420 times 12.
Wait, no, that's 40.
5,040? See, you only had to put in one multiplication in your calculator. Now, I want you to look at C. Now, I want to show you something after we do C the long way that would allow you to do it a lot shorter. And please do not be sitting there saying, well, I already know how to do this on the calculator the fast way. Just be patient with me. I'm just trying to show you some kind of neat stuff. And then we'll go to your calculator. Okay, 8 factorial. How would you write down 8 factorial? Okay, I want you to do that. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, thank you. You skipped 5. That's not good. Now, 4 factorial is 4 times 3 times 2 times 1. Yeah, so if you see, that all cancels, doesn't it?
So we're going to be wait, so they have the same.
Yep. Now let's go to your calculator, but let's see if we can come up with just 2 numbers to multiply together. That 30 times 56. Do 30 times 56. Let's see what you get. Is that right? Do you have questions so far? Now, I want to show you something that's really pretty cool right here. This right here is 4 factorial, isn't it? What's this right here? That's 4 factorial. So I could have saved myself a lot of writing because I could have done this. I could have written 8 times 7 times 6 times 5 times 4 factorial, because the rest of it is just 4 times 3 times 2 times 1 divided by 4 factorial. And I could have said, "Rrr, rrr." Okay. Now I'm going to show you how to do them on the calculator. Okay. Please get your calculator. And listen, let me teach this instead of, if you're jumping ahead, that's fine. Just, Now, where you're looking, math, go right there. Math, right there. Yours does not have all of the things that mine does. Yours does not have this frac on the end, the fraction. Yours has math, num, complex, and probability. Is that right? That's what yours has. Now, we want to go to probability. So we're going to arrow over until we get to probability. And look at option 4. Option 4 is the exclamation point for factorial. So we want to do 10 factorial. So what we're going to do on our calculator, quit, go back to a clean screen. You're going to type in your 10, and then you're going to go get that factorial. Math, option 4, hit enter. There it is. What number is that? 3,628,800. Good. That's exactly what it is. The next one says 12 factorial. Run that on your calculator. Full 479 million, right. 479,100,600. Not quite. One digit off. One digit off. Yeah. Now, look at C. Now, before we do C on the calculator, we're going to do it like we did the short way on the first C right above it. Now, could we write this out? If we start writing out 32 factorial, it's going to be 32 times 31 times 30 times 29, and that would take us a very, very long time to write out, wouldn't it? But what do I have in my denominator? 30 factorial. So I could write 32 times 31 times 30 factorial over 30 factorial. That's right, and they cancel. Cougar, do you have a question? Okay. So it's 32 times 31. Yeah. Now, let's talk about how to do that on your calculator. I want you to go to your fraction command, which is alpha y equals option 1. And type it in. Type in your 32 factorial. Huh? Sure, but sure. Let me show you something else that works, that do you notice here, and you're like, it's not that big a deal, but it does save you some keystrokes. When you arrow from math to prob, you arrow, 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 right? What if you arrowed one the other way? This way. Now for you, you just have to arrow one time because yours doesn't have that fraction command on the end. Okay, so let's continue. Factorials are used in many areas of mathematics, but primarily in permutations and combinations. Now, a permutation is a selection of a group of objects in which order matters. I'm going to give you an example of one very recently, like Saturday, the Kentucky Derby. Now, we're just going to pretend nobody got disqualified. How many horses run? Yeah. Okay. So I don't remember how many horses ran. Let's say 15. I don't remember. Were there 20? Then let's say, okay, so let's say 20 horses ran in the Derby. How many choices are there for win, place, and show? Do you know what win, place, and show mean in horse racing? Win means first place. Place means second place. Show means third place. Win, place, and show. I don't know why I don't know. Win, place, and show. Now, if 20 horses run, how many ways are there to have the 3 winners? How many options do you have for the horse that wins? How many options do you have for the horse that places second? 19, and third? You have 20 times 19 times 18. That's the very beginning of 20 factorial, isn't it? Okay. No, I'm not going to go there yet. Okay, let's go back here. If the student council of 10 students wants to elect a president, vice president, secretary, or treasurer. So the student council has 10 members, and they need to elect 4 officers. Okay? How many choices do they have for president? 10. There are 10 students in the student council, and any of them could be the president, right? So they have 10 choices for president. How many choices do they have for vice president? 9, because the president can't be the vice president. How many choices do they have for secretary and treasurer? 10 times 9 times 8 times 7. Oh my gosh, that's the beginning of pen factorial. Okay, if you've got your head on your desk, you're going to pretend you're interested in what we're doing, whether you are or not. I'm not going to put up with it. All right. When I do a permutation, I do them just like we just said. I'd say president, vice president, secretary, and treasurer. I got 10 choices here, 9, 8, and 7, and I'd multiply them together. Go to your calculator, do it. Let's see how many different ways 10 people could make that set of officers. 5040? Would you have thought it would be that high? No. Okay. There is a formula that you can do this with as well. I'm not going to use the formula unless I just am told you have to use the formula. I'm going to do them this way. This is easy, right? Good. Now, let's take a look at this. The number of ways to arrange or permute n objects, take an r at a time. So you look back here. How many objects? Taken how many at a time? We had 10 objects taken 4 at a time because we needed 4 officers, right? 10 people to choose from, 4 slots to fill. Now, order matters. If Jackson is the president, that's a whole different set of officers than Jackson being the vice president. Order matters. Now, you see this P right here? That stands for permutation. And the way you would write what we just did, we'd say it's a permutation of 10 objects taken 4 at a time, like that. Now, let's take a look at this. This is what you need to write in that box, right here. It's n factorial divided by n minus r factorial. So for this question, what would be the numerator? 10 factorial over, and what's 10 minus 4? 6 factorial. Now, if we write this out the way we were writing them out at the top, I want to show you what happens. We start writing out 10 factorial. 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Guess what happens? And isn't that exactly what we did just a minute ago? Only, yeah. I'm going to show you what it's better for. This formula is better for big numbers because the calculator will do the whole mess for you. You're exactly right. Go to your calculator. Now, I want you to go back to the probability screen. Look at option 2. If I told you we're going to take this whole group, which today is 29, 28, 27, 26, which today I think is 26 of you. And I want to figure out how many ways, oh boy, let's see. How many ways could I take 10 of you and put you in an order? That would be 26, 10, right? Okay. So you would have 26 of you, and we would choose and put you in an order with 10 of you. That is going to be really hard just to do on paper and pencil because it would just be so long. This is what we're going to use right here, number 2. So you say, okay, how do you do that? Let's do 10. It's a permutation of 10 taken 4 at a time. So here's what you got to do. You've got to type in this number before you even go to that command. So type in your 10. Then go to that command. And then type in your 4. Yeah, it's the same thing. Yeah, same thing. Yeah. Yep, same thing. This is just real helpful when your numbers are bigger. All right. So let's go here. Now here's what we're going to do. That's a permutation of how many objects? 6 taken 4 at a time. I want us to write out the formula. Now remember, the formula is this. Which of those 2 numbers is n? And then r is, no, r is 4. R is 4. So the formula says n factorial over n minus r factorial. You good there? Sir. 6 minus 4. Right here. If any of you have wireless earbuds in, they need to come out, okay? All right, so let's write it down. What's the numerator going to look like? So 30 times 12 is 360? Hmm?
Oh, no, I wrote it.
360? Okay. I love you, Karen. Okay, let's look at B. Now, I want you to think about this one for just a minute. I have these 5 people right here, taken one at a time. How many different ways can I pick one of them? 5 ways? Okay, so let's do the formula. Well, that was fast. Get in here. Now, the formula says n factorial over n minus r factorial. Okay, formula, n factorial. So what's that? 5 factorial over 5 minus 1 factorial. So this is going to be 5 times 4 factorial over, which is 5, which is 5. What's confusing you about C, my dear?
6 minus 6 equals 0.
But I got another answer other than 0.
Aha.
Yeah, you see it.
Uh-huh.
It's 1.
5 minus 1 factorial.
But that's
All right. All right. Let's do the formula. What's the formula say? What's the formula say? N factorial over 6 minus 6 factorial.
But you still have all the time.
Wait a minute.
Times 5 times 4 times 3 times 2 times 1.
Now, let's talk about what Giselle just said. I got 6 people, and I need to put those 6 people in some particular order. How many slots, how many options do I have for my first slot? Right? That's 6 factorial. If the answer to this is 6 factorial, what does 0 factorial have to equal? 1. 0 factorial is 1. Okay, now let's talk about this. Let's talk about this. Oh, you bet. I would absolutely encourage you at the top to write 0 factorial equals 1. She's speaking a foreign language. I don't know which one, but okay. Okay, so let's talk about why 0 factorial is 1. Now, I could write the number 5 as, let me think how I want it. I wrote this down so I would remind myself exactly how I wanted to do it with you guys. Okay. I can write this. Let's take a look at 6 factorial. Now, 6 factorial, yeah, I don't want to do that. I want to do, wait, I'm going to turn, no, I got it. That's what I wanted to do. That's what I wanted to do. Now, really? You sure about that? 6 factorial divided by 6. Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And if I divide that by 6, then that's 5 factorial. This is that one. Now, so 4 factorial would be 5 factorial divided by 5, because that would be 5 times 4 times 3 times 2 times 1 divided by 5. But the 5's factor out, and that's 4 factorial. We good so far? Yeah. Okay. Oh, thank you. I was like, what are you? Okay. So, you can probably guess the pattern I'm trying to show you. 3 factorial would be 4 factorial over 4, which would be 4 times 3 times 2 times 1 over 4, which is 3 factorial. 2 factorial would be, so that's 3 times 2 times 1 over 3. That's 2 factorial. You with me? 1 factorial then would be 2 factorial over 2, right? Which is 2 times 1 over 2. So 0 factorial would have to be 1 factorial over 1. Huh? Yes, yes. 0 factorial and 1 factorial are the same thing. I think that's kind of cool. So, at the top of your paper, please write this. Did we finish that whole first page then? Yeah. Did we decide what 6P6 was? 720? Okay. Now, all I want you to do on these, use your calculator. All I want you to do is use your calculator to get the answers. Go. P42. Do it on your okay, if you are not touching your calculator, physically touching your calculator, you're not doing what I'm asking you to do. Joanna, calculator. Jacob. What's 4P2? 12? 60? 60? Okay, good. Oh yeah. Oh yeah. Now, you have 105 employees, and you have I don't like committee. We're taking that word out. We need to select a president, a secretary, and a treasurer.
Oh my God, there was a question like this.
I'll throw it out because you wouldn't have gotten there. I won't grade that one for you. A president, a secretary, and a treasurer. How many ways can this be done? I am not going to use the letter P right now. I'm going to do it the way I did it yesterday. How many, listen, we got president, a secretary, and a treasurer. You have 105 ways to choose the president, 104, 103, and what do you do with those numbers? Do it. Pretty good sized number, isn't it? 1 million? 1,124,000? That's a lot. Too much for you. Now let's talk about the formula. If we set it up with the P, what number would go first? 105. And I'm permuting how many? 3? Hey. Well, did you do 105 times 104 times 103?
No, like the 150 and the.
It's not 150, it's 105.
Oh!
I told you to again.
Let's do the formula before you would go to your calculator. What's the numerator? It's n factorial over n minus r factorial. So what's the top? 105 factorial over 105 minus 3, 102 factorial. But look, isn't that this? Because it'd be 105 times 104 times 103 times 102 factorial over 102 factorial. Why do all that mess when I can just do this? Okay? Now, next. Now this, I'm going to show you, this is a weird thing. You are setting the combination on a 3-digit lock. It's got the word combination in here. And today we're talking about combinations and permutations. But a combination on a 3-digit lock is a permutation. Because the order of the numbers matter. If I tell you the numbers on my 3-digit lock are 2, 5, and 9, what order? The order matters. So it's permutation. I don't remember. I don't remember.
Oh, it was the whole cat nesting, like how the order mattered.
Oh, yes. Yes, yes, yes. Okay. Look, does the order of the numbers matter? So it's permutation, so I'm going to do it my way. How many digits? 3. 1, 2, 3. It's a 3-digit lock. How many choices do I have? 10. Can the digits repeat? Could the code for my lock be 222? Sure. So, how many? Not 10,000. A 1 with how many zeros? How would we set it up with a P? 10, taken 3 at a time. Uh-uh. It better not be. If it is, I'm all messed up.
Yeah, it's so
Huh? 10, 0, 1, 2. Oh. Oh, okay. So here's where we have to be careful. Here's where we have to be careful. This problem then needs to say, can you repeat the numbers or not? Because when you do it with the P, that means what? It means the numbers are not repeating. So we have to, this problem doesn't really give us enough information, does it? So, well, so this would be, it either needs to say no digits can repeat or digits can repeat. Yeah. And it doesn't. So if it said digits can repeat, then you're going to do this. If it says digits cannot repeat, then you're going to do this, right, which is the P thing. Well done. Well, no, that's when you ask me and say, which one? And I'll say, and then I'll say, class, let's all do it this way. Now, let's do that one as a permutation since we're doing permutations. Let's say no repeats. No repeats. Okay. Combinations. This is the last part we got to do. Combinations. Now, I have you all as a group of 20, however many, 8 now. I think they came back, so let's say it's 28. Now, I need to pick a committee of 3 people. A committee, no, I didn't like it in that other context. Give me a minute. Give me a minute. Now, so let's say that I pick a committee of Giselle, Katie, and Kaylee. Now, Giselle, Katie, and Kaylee. They are a committee. Does the order matter? It's just a group of 3. Does the order matter? They are the prom committee. Order doesn't matter, does it? No, the order doesn't matter because they have no specific job. They are the committee. So whether Kaylee sits in the first seat and then Giselle and then Katie, that's fine. But Katie could sit in the first seat and then Kaylee could sit in the next seat and then Giselle could sit in the third seat. Okay? A combination order does not matter. All right. Now, here's what we're going to do. I am going to take you 3. I'm going to turn off this because if you're watching, you can't see this and it will make no sense. The green circled is the permutation part. This part gets rid of the duplicates. Okay? All right. So let's look at this bad boy right here. Now, I'm going to write it out, okay? So what's the top going to be? 22 factorial over, and what's 22 minus 20? 2 factorial times 20 factorial. (22 factorial is 22 times 21 times what is 2 factorial? That is 2. 2 goes into 22. So your answer is 11 times 21. 231. Go to your calculator. 22C20. Let's run it on your calculator. 22 C20. I do know.
But it's wrong. It can't be right.
Oh, I do too. I know exactly how she feels. They've got their AP Calculus exam next Tuesday, and this is their. Yeah. No, I gave AP Lit this morning. AP Calculus. I am not allowed to give the AP Calculus exam. All right, let's do this one by hand. 12C8. Now, what's our numerator going to be? 12 factorial over. Now, what's n minus r? 4 factorial times, no, 8 factorial. So I've got the 12 times 11 times 10 times 9 times 8 factorial over 4 factorial times 8 factorial. Now, 4 factorial is 4 times 3 times 2 times 1. Look here, what's 4 times 3? 12, 12. 2 and 5. Yeah, and 1 is, 1. Hey. So,
It's like, because you know how you did it on A?
I did what, where on A? What? What A?
Right here, it's like next to that one. If that was like,
Oh, there?
yeah.
Yeah.
But you know how you put the 2 and all inside and then 2?
Like we did with 2 factorial.
Yeah.
Oh, because I knew in my head 2 factorial was 2. Yeah, I mean, writing down the 1, when you multiply by 1, it's...
Wait, no, like what I'm asking is, can you not put the 4 all inside as well?
I did.
No, you put the 2 and the 10.
Right, and then you put the 4
Hold
on
up. You
It's
wrote
4
it out.
factorial is 4 to
I never.
Yeah, it's 4 different numbers.
the 4 and the 3 and the 12.
Look. Look, okay, so look, let's go back here then. 22 times 21 times 20 factorial, right? Divided by, now, I just thought in my head, 2 factorial is 2. Because 2 times 1 is 2. So that's, I just did 2 times 20 factorial. 2 goes into 22 11 times. I would contend to you I'm doing exactly the same thing over here.
Putting a 2 there and a 4 factorial there, like when that's actually a 2.
So it makes us so
that 2
factorial.
factorial. It makes us want to just mark up on the board. Yeah, that's 12. That's what I did.
Oh, no, no.
With the
Yeah, that's I thought the 4 could go into 12 and the
No, the 4 can go into 12, but this is not 4. This is 4 factorial.
right. That's
But
what
you
we
didn't
put.
put 2 factorial there to put the 2.
I was gonna say that's
But because they're the same thing.
I don't understand.
but that could.
Okay, all right. Okay.
Okay.
Are you a little more?
Yes.
Okay, all right. All right. No, I hear what you're saying. It took me a little bit, but I got what you're saying. Gentlemen, if you had wanted to, 4 factorial is easy to do in your head, right? 4 times 3 times 2 times 1. What's 4 times 3? 12. Times 2? 24. So 24. So you could have said that's 24 times 8 factorial. You could have done it that way. It wouldn't have been a problem. The answer is 45 times 11. There's a slick way to multiply 2-digit numbers by 11. 4 and 5 and a 9 in the middle.
Oh, no, that's what I got.
I like this multiply by.
Nice, isn't it? Now, you can run those on the calculator. I'm going to assume you can run those on the calculator. All right, let's take a look at this. All we're going to do here is set them up. We're going to decide if it's a combination or a permutation. We're just going to set them up, okay? Look at number 1. You have 105 employees and you need to select a committee of 3. How many ways can this be done? Is this a permutation? Permutation order matters. Combination order does not matter. Right. Permutation is officers. Combination is a committee. So, what's this? 105. Yeah, that's a combination, and you do 105C3. This is a committee because the order does not matter. So we're going to use C. Say again? Yes, absolutely. Oh, that's good. That's good. C for committee, P for president. Well done. Well done. Yeah, can I make a song? The answer is no. If I had to write songs for a living, I would starve. Okay. All right. Yeah. All right. A team of 17 soccer players needs to choose 3 players to refill the water cooler because it's heavy. Is this a combination or a permutation? Combination. It's a committee. So 17, C3. Now, all we want to know on these last ones, is it a combination or is it a permutation? All right, look at number 1. A team of 8 basketball players needs to choose a captain and a co-captain. Permutation. Good. There are 45 applicants for 3 computer programmer positions. That's a combination, right? Now, we do not have time to do all the work here. Here's what I want you to do. I want you to do what we did up here, but let's put the numbers with it. Look at letter A. You are planning a trip to 3 countries. There are 7 countries you want to visit. One trip will last 1 week, the second trip will be 2 days, and the other one will be 2 weeks. Now, the question is, does it matter which country you pair with the length of time of the trip? Is a trip to France for 2 weeks the same as a trip to France for 1 week? No, those are 2 different trips. So is this a combination or a permutation? That is a permutation of how many? 7 countries, and you're picking 3. Look at letter C. 5 out of 13 students will ride in a car instead of a van. No, it's not 5C13, it's 13C5. Now be careful reading this one. A group of 25 people are going to run a race. The top 8 finishers advance to the finals. Does it matter if you finish first or if you finish 8th in terms of are you advancing to the finals? Doesn't matter, does it? It doesn't matter. It's a combination. Because if you finish first or if you finish 8th, you're still going to the finals. Combination of 25 choose 8. There are 15 applicants for 4 jobs: computer programmer, software tester, manager, and systems engineer. Is Chloe getting the job for computer programmer the same as Chloe getting the job for manager? No. So order matters. Good. 15, P, 4.